Assalamualaikum warahmatullahi taala wabarakatuh. Apa khabar semua?
Waalaikumsalam, sir.
Sehat semua? Okay, today we're going to do the second derivative test. I will just summarize the test again. And then we will look at application, all right, of the second derivative test, which is chapter 10. After that, we're going to move on. The next topic that would be on the partial derivative. So hopefully, we can start with the partial derivative today. Now I have one announcement. We missed the class last week on Monday. Due to some reason, I could not make the class on Monday. So what we'll do, we'll have a makeup class on Saturday. Okay, this is to cover the class on Monday. And I know everybody has, not everybody, many of you has class on Friday, Saturday, not Saturday, Friday, Thursday, things like that. So I have no choice but to have a class on Saturday on the 24th, this Saturday. And of course, the time, I think I keep the time, same time, 10 a.m. Okay. So I hope, most of you can make it. So that is a makeup class to cover the class that I canceled on Monday last week. Okay. Any problem with Saturday? Do you have a class? Anybody has class on Saturday? Okay.
Yes, sir, I have class.
What time do you have class on Saturday?
10 until 12.
Oh, 10
Yes,
until 12.
I also have class at on Saturday.
Yes, I have leadership class.
Is it from 10 o'clock?
Yes,
Okay, in that case, we make it, okay now. How many people has class on Saturday, 10 a.m.? How many people? About how many? I have 2 people. Is there anybody else having class on Saturday?
I have class, sir. I also have class, sir.
Oh,
I also have class too.
Oh, okay. In that case, what we do, I will make it Saturday 8 in the morning. Okay, 8 a.m. 8 a.m. tadi kelas dah.
I also have class 8 a.m.
I also have class, sir.
Yes, sir.
Apa
I have
kelas
class.
Saturday? Ada kelas Saturday?
Yes, sir.
Yes.
On eight. Eight
Ayo,
until
apa
10.
macam ni?
Until 12.
Tengoklah. What about lepas tarawih malam-malam? Ada kelas? Okay, so in that case, we will do the class, all right?
No,
I'll do the class on Thursday, okay? Thursday, 10 p.m. Okay.
Thursday 10 p.m. Oh,
10 p.m. malam. Ada kelas kat malam?
What that is it?
Tadi kalau ada kelas kat malam, tengoklah juga nyanyi ke budak. Okay, Thursday, 10 p.m. Okay? Unless, some people has objection to that time, I don't think so. By 10 o'clock, the mosque is already closed. Yeah, by the time you come back, I don't think it's 10 p.m. 10:30 lah. 10:30. Okay, in Ramadan, kita belum buat kelas malam. Because, you stay up longer at night. So I think 10:30. Okay, I'll try to make it 1.5 hours or 1 hour depending. But we have to cover that class on Saturday, on Monday. So as of now, confirm. Okay, confirm Thursday. This Thursday, what is the day? The day is 22nd. Kita nak Thursday ke Friday? Friday kot. Friday ke Saturday? Because we have a class on Wednesday. Nanti Thursday ada kelas lagi. So Friday lah. Okay, so Friday 10:30 p.m. Friday is on the 23rd.
Sir, Friday pukul 10 malam ada kelas.
Ada kelas? Masya Allah.
Itu, sir.
Ha? Macam tu kita buat kelas Sunday ada Sunday. Ada kelas kat Sunday?
Tak ada.
Tak ada. Kita buat Sunday lah. Okay, I don't think we are traveling because now it's PKP. So we do it on Sunday. Okay, so Sunday we maintain the time 10 a.m. Okay, we maintain the time 10 a.m. And that will be the last straw. Okay, so Sunday 25. So yang ni out 25, 25th of April, 10 a.m. Okay, Sunday lah senang cerita. Alright, Sunday class, and then on Monday you have also a class. But that's fine because we have a problem, making the schedule. Everybody is busy having classes on Saturday, Friday, tomorrow. Alright, so I give you some homework questions before I forget. Homework question, okay, 10.1. This is on the application. I haven't given you application here. Application first derivative test. So what you do for these questions, you just apply the first derivative test. 52, 53, 57. Okay, that's 10.1. 10.2, the one that we are doing now, okay, the second derivative test. I would like you to do 9, 10, 13, 15, 16. Now this, you only do the second derivative test. You know, sometimes the question asks you to do some other things, but you don't do anything else. Just do the second derivative test for maximum and minimum. So this is the thing that I need to do today, all right? I think I started that already on Wednesday. So today I'm going to make it, I will do it again on the principle. Then we're going to do the application, all right, which is 10.3. 10.3 and 10.3 and 4. 10.3. Okay, so yeah. So after that, we are done with the chapter. The application is 10.3. Okay, good. All right, now, what is the second derivative test? Like I said earlier, by using the second derivative test, we can determine whether the function has a maximum or minimum with relative ease. That means the test would be straightforward and it's compact, and we don't have to do to determine the intervals for which the function is increasing and so on. We'll just make use of the second derivative test. So here we're going to relate, all right? We relate the second derivative to the function, whether the function has a maximum or minimum at the critical point. So that is the test. Okay. I hope my internet today will be okay. All right. Now the second derivative test is the following. Okay, the second derivative. We consider a function y equal to f of x. And of course, this function is differentiable. And what you want to do first is that you find the critical point. So find the critical point. Of course, we are taking the first derivative, okay, point or points, if there are more than one. That means y prime equal to f prime of x equal to 0. Now say the critical point is at x0, y0. So we have done this. Okay, first step we know already. Now, secondly, we are going to determine, or we're going to find the second derivative. So here you get the second derivative, that is y double prime equal to f double prime of x. So you take the second derivative. And then what we do here, we evaluate. Okay, you evaluate the y double prime at x0, y0. Okay, so here at x equal to x0, you want to see what is the nature, okay, the nature of the y double prime. So at x equal to x0, if, okay, if the f double prime at x0 is positive, bigger than 0, what will be our conclusion? We conclude that the y, or the function, has a relative, or sometimes, you know, you don't have to say the word relative, relative minimum at x equal to x0. And of course, that we mean is that the point x0, y0. Okay, so if the f double prime at x0 is positive, bigger than 0, what does it mean? It means that the function has a minimum at that critical point. Okay, all right. So that is the first possibility. Now, second possibility, you may have f double prime at x0 negative. Okay, are you done here? Finished? Yeah. Okay. Second possibility, we may have f double prime at x0 is less than 0, negative. So what is our conclusion? Y, or the function, has what? Has a relative maximum, right? At x0, y0. So the critical point is a relative maximum for the function. Or we say that the function has a relative maximum at x0, y0. So f double prime, okay, f double prime. Okay, f double prime negative, you have a maximum at the critical point. Now, the third possibility, you may have f double prime at x0 equal to 0. All right, so here we cannot conclude. So there is no conclusion. It won't be a maximum. It will not be a maximum. We may have an inflection point. Okay, inflection point. Now, inflection point, we are not going to cover that, because if inflection point, it's not a maximum, it's not minimum, then it doesn't serve our purpose for application. Okay, so case number 3, we don't do. We are interested only in A and B, whether you have a maximum or minimum. Okay, all right. Now, inflection point, what is inflection point? inflection point is something like this. We just have an idea of how inflection point look like. Inflection point will be something like this. It is not a maximum, it's not a minimum. It's like you know, when you go up a mountain, you don't reach the peak. Okay, you reach some plateau, that means some flat area, but after that, it is going up again. It is not going down. So it will be something like this. You have the curve going up, all right, reaching some critical point over there, okay, and then it goes up again. So here at this point, you have f prime equal to 0, okay, but f double prime is maybe equal to 0, or it is equal to, it's undefined. Okay, sometimes it's undefined. So you may have inflection point. And it can also be the other way around. The curve is going down, right? And that means you may have a minimum there, but instead of going up, the curve go down. So that is also inflection point. So that is inflection point, all right? So for more detailed inflection point, you can look at some pictures, you know. They draw a very good picture in 10.2. Okay. So you want to see, just look at the picture, okay? Just look at some diagrams, more beautiful diagram, 10.2. But this is the idea, okay? Inflection point. It's like, it's not a maximum, all right? It look at it from the one side, it look like a maximum, but from the other side, it is not, okay? Because the curve keep on going up, or the curve keep on going down. All right, okay. So that is possibility number 3, which we are not interested in. So let's look at 1 or 2 examples of the second derivative test. So let's consider a simple example. Number 1, let's say we have y equal to x squared plus 5x minus 9. So we have a quadratic function, and we know how it looks already, all right, from the first derivative test. But now, you know, we want to show the same thing by making use of the second derivative test. So here, to find or determine whether, I think maybe determine whether the function has a relative maximum or minimum. All right, and then sketch the graph. So what you do, number 1, you get the critical point. Okay, find the critical point. That means y prime is equal to 0. So what is y prime? Y prime is equal to 2x plus 5. All right, set that to 0. 2x plus 5 equal to 0 for critical point. Then what you have would be 2x. I think what we should do, not y prime. Okay, set y prime equal to 0 for critical point. Then what you have is 2x plus 5 equals 0. X is equal to negative 5 over 2. That is negative 2.5. So that is our critical value of x. So what you do now, find y. Okay, we call that x0. Okay, critical point x0. So you need to find y0, or just say y. It's okay also. No? So you find y0, okay, equal to something. Substitute into the original function. So you find the value of y, which is y0. So somebody has time, fine. Okay. Somebody has calculator, can you find it? What is the value? I just need a few people to do it. So you got the value of y, okay, at x equal to negative 2.5. And what is the value? We are going to determine. Now, what you do next is that you find the second derivative. Okay, you find the second derivative. So, what is y double prime? Y double prime is equal to, so go back to the function. I didn't write down the function, we didn't remember. 2x plus 5. So what is y double prime? Y double prime is equal to 2. 2, the constant. Okay, so now what you do, you evaluate y double prime at x0, which is equal to negative 2.5. Okay, and since it's constant, then it's very easy. Y double prime is equal to 2. Okay, now 2 is positive. Okay, so what is our conclusion? Our conclusion is the function y has what? Has a relative maximum or minimum? Or
Minimum relative.
has a relative minimum at
Minimum.
because positive at x0 equal to negative 2.5. And if you find the value of y at negative 2.5, then we say at the critical point. Now, what is the value of y at negative 2.5? Anybody found it?
Negative 15.25.
Negative. Apa tadi? 15.25.
15.25.
15.25.
Ah.
Yeah. So you know already, okay, where is the critical point? The x is negative 2.2, negative 2.5. The value of y is negative 15.25. So you have some idea where the location is. So in order for you to sketch the graph, we put the x and the y, and then you put the origin here. So negative 2.5, negative 15.2 will be somewhere here. 2.5, let's say 2.5 here, negative 15.5 will be somewhere there. So that's it. That's the critical point. And it's a what? It's a minimum. So minimum, the curve will look like this. So that is y equal to tadi apa tadi? Now x squared plus 5x minus 9. X squared plus 5x minus 9. So what you need is only that critical point. Okay? So negative 2.5, negative 15.25. What you get will be a minimum. So therefore, the curve will look like that. Okay? Okay. Any question about this? All right, good. I'll give you another example. Okay, let's say we have the following. Example number 2. Let's say I got y equal to 4x squared minus 20x plus 51. No, actually I want to put a minus. Okay, minus 4x plus 20x plus 51. So now I want you to do, okay, find, determine whether this function here, correct, has a maximum or minimum, and then sketch the curve. Okay, do it now. Practice. practice just to get a better idea of the method. Okay, all right. I give you 2 minutes. Right? For baby, I don't have a student named Baby. Okay, if you are Baby, I don't think you belong to my class. So you are in the wrong class. Okay, I don't have a student named Baby. So Baby, okay, if your name is still Baby, I hope you can leave my class. I don't have a student named Baby. Siapa lah Baby ni? Mengada-ngada nak letak nama Baby. Okay, you got it? Do we have a maximum or minimum at the critical point? Ramai lagi orang tak letak gambar dia kat sini. Sekarang nak cakap apa lah? Okay, you got it? So if you go to the question, okay, you have a maximum or minimum? Yeah.
Maximum relative, sir.
Relative maximum kan? Because if you do the okay, if you take the first derivative, you will get negative 8x plus 20. So you get the critical point. All right. So what is the critical point? Critical point berapa? X0, Y0 equal to what? Berapa critical point? Anybody tell me?
2.5.
2.5?
2.5, sir. 2.5. 76.
76. Oh, 2.5 kok. Bagus, pandai dia. Alright. So you have the critical point. Alright. You do set it to 0. Now you do the second derivative. Okay. You do the second derivative. What we get will be what? Negative 8. Is that right? You got negative 8?
Yes.
Yeah. Negative 8. Okay. So you evaluate the value of the y double prime, okay, at x equal to 2.5. Because that is the criteria for maximum or minimum. So now at x equal to 2.5, y double prime is equal to negative 8 because it's a constant, all right? And that is less than 0. So what? So the function y has a relative, or you don't have to put relative, that's fine, maximum at 2.5, 76. Okay, so you get a maximum. So now to sketch the graph, all right, to sketch the graph, we do same thing. We know the critical point already be here. So you can imagine, you know, where is the location of the critical point? It will be somewhere up there. All right. So you sketch the graph. You need what you need is only the x and y. 0, 2.5, 76 will be somewhere there, up here. and that is a maximum. And you know the graph will look something like this. Okay, so you can extend up to that. So that is the function y equal to negative 4x squared plus 20x. Okay, all right, I'll give you another one. Okay, this one, I just need you to find the critical point. Okay, I'll give you another one. Suppose here, example 3. Let's say we have f of x equal to 2x cubed minus 12x squared plus 15. Okay, now I want you to determine whether the function has the maximum or minimum at the critical point or the critical points and sketch the graph. So first of all, you find the critical point. Okay, so now I want you to find the first derivative and see what are the critical points. So here you will have two critical points because it is a cubic function. So therefore there will be two critical points. So I want you just to find the critical point. Okay, do it now. I'll give you 1 minute. Okay, tadi baby itu, okay, can you put your real name? And then okay, you got it? How many critical points should be there? Should be 2. Okay, what are the critical points? Okay, anybody got the critical point yet? Okay, you got the f prime of x equal to what? Equal to 6x minus 24, 6x minus 24x. Betul tak? Okay.
Yes.
Berapa dapat critical point? What are the critical points?
X0.
Saya dapat 2, sir.
Dua.
Dah mustahil ke?
Okay, for critical point.
0 and 4.
Everybody got it?
Okay.
F prime equal to 0.
Yes, sir.
All right.
Yes.
So therefore, 6x squared minus 24x equal to 0. So you factor out the 6x. Okay, so you take out the 6x, and then you got x minus 4 equals 0. So here you have two critical points. So first, 6x equal to 0. That means x equal to 0. So you find the value of y, right? And then the other one, for the expression to be 0, x minus 4 should be equal to 0. Here you got x equal to 4, and of course you find the value of y. So here you have two critical points. So now you have to do, all right, you have to do the test for each. Okay, for each. That means you repeat. First you do for x equal to 0, all right, and then you do for x equal to 4. So you do it for the test. You do the test for each of the critical points. So if there are 3 critical points, that means you have to do the test for each of them. So you have to do it 3 times. Okay? So you have to repeat the test for each of the critical points. So I want you to finish it up. Okay, that is just another homework question for you. Go home, finish it up. So you do the second derivative test. You do the second derivative, and then you evaluate the value of the second derivative at x equal to 0, and then see what happened to that, to the f double prime at that value. So you conclude whether you have a maximum or minimum. And then you repeat the test for x equal to 4, and then you do the conclusion. And then sketch the graph. Okay? So that will conclude the second derivative test. Okay, any question? So next, okay, I give you a few homework questions. I would like you to do those questions. So now we do the application. So for application, we look at the book. Okay, look at the book. It's in 10.3. I think 10.3 application. So you go to 10.3. Look at application. So there are similar application, which is revenue, cost, profit. So it's nothing new. The only new thing is you apply the second derivative test. Okay. So look at example number 1. So here 10.3, example 1. That is on the revenue. So if you look at the revenue, we are given the revenue function. Okay, revenue function is equal to that function. So what you want to do here is find the maximum revenue. All right, find the maximum revenue. So you apply the second derivative test. All right. So here you have a cubic function. What you do, we take the first derivative, then what you will get would be a quadratic function, and then you find the roots for the equation. But this is not as simple as the cubic function that I gave you earlier. You know, this one is a little bit, you have to apply the root formula. So let's do that. So you have, R prime equal to what? R prime is equal to 8,000 minus 80x minus 3x squared. So for critical point, okay, for critical point, you set R prime equal to 0. So therefore, you got 8,000. Sometimes, when we do this thing, I prefer to have the x first. So negative 3x squared, negative 80x plus 8,000 equal to 0. And you can also multiply by -1, or to the left and to the right. You will get a positive 3x squared, everything. So you multiply by -1, okay? Both sides. Then you have get rid of that negative, sometimes easier. So you got 3x squared plus 8x minus 8,000 equals 0.
Sir, bukan 80x kah, sir?
Huh?
Bukan 80x.
Yeah, 80x. Yeah, I missed that 0. So it should be 80x. Here 80x. So what you do here, all right, if you don't, I think the easiest way to find is how to get the roots of this equation. X equal to 4x squared, for function ax squared plus by plus c equal to 0. There is a formula. I think negative b plus or minus apa benda square root dia, b squared minus 4ac, tak silap saya lah. Okay, divided by 2a lah. Something like that. So to confirm this one, you check chapter 0 ke chapter 1. Okay, ada dia bagi formula. I think you know the formula from your high school. I'm not sure about this, but I think if I remember correctly, okay? Or you can use, when I was in school, my teacher used to teach me the cross formula, okay? The cross formula. So you have to do that. Anyhow, everything is already given. So if you forgot this thing, check the formula. So what you got, okay, we just move forward. So you factor that out. You got 40 minus x. The 2 jump. Okay, so you check this one. Okay, check that one. Use the formula or use this formula. You will get x equal to 40. And then x equal to berapa? X equal to negative 200 over 3. So one is positive value, the other is negative. Now, fortunately, our life is not as difficult as it should be, because in application, we deal only with what? We deal only with x bigger or equal to 0. Because here we are looking at revenue. Okay, we are looking at quantity. So quantity for real life, you don't have negative quantity, right? So we deal only with x bigger or equal to 0. So the independent variable, okay, we only consider positive value or 0. So therefore, x equal to negative 200 over 3 will not be included or will be excluded. But if you want to do the test, that's fine, just for the sake of doing the test, that's okay, right? But you don't have to. We only look at the positive x. Yeah, I think that may be a good exercise, So you can just practice. Okay, practice the test. So for practice, you do it. Okay, do the negative x. But actually, when you answer application question, you don't have to, right? Because negative plus quantity not applicable. Okay, all right. So now what you do next is that you take the second derivative. So what is the r double prime? The r double prime is the derivative of the r prime. What you get will be negative 6x, right? Negative 6x minus 80. Okay, so that would be our second derivative. So now you have to evaluate the value of the r double prime at the critical value of x. So at x equal to 40, okay, what is r double prime? Now the r double prime is not as simple as what you have in earlier examples. It's a constant. Today, or for this example, it is not a constant. It is a what? It is a variable. It's a function. So what you do, you substitute. So r prime is equal to what? Is equal to negative 6 times 40 minus 80. So you got that multiplication. You multiply that out. What do I get? We get negative 320. Okay. So negative 320 is less than 0. It's negative. So what? So what is our conclusion? So revenue has what? Has a relative maximum. Okay, at x equal to 40. Okay, so now you have to find what is the r. Okay, what is the r at x equal to 40? So that will be our critical point, and that critical point is the maximum point. Okay, so at x equal to 40, if you look at that example, the revenue is equal to 192,000. So we just find determine it at x equal to 40, r is equal to, substitute, okay, substitute into the r, you will get 8,000 times 40 minus 40 squared minus 40 cube. And what you get is 192,000. So that is the revenue. So in other words, that is the critical point. Okay, so x0 r0 is equal to 40, 192,000. And that critical point is the relative maximum. Okay, so in application, there is a meaning. Okay, there is a meaning to the value of the dependent variable, or which is the value of y. All right, that means that will be the maximum value of the function. All right, okay, any question? So now you have that, and x equal to 40, the revenue is equal to $192,000. And that is the maximum revenue. So what you say is the following. We are going to conclude, okay? You're going to describe this. So you're going to describe that point, okay? You're going to describe that point. So what you say is this, okay? What you say is this. You can rephrase it, wherever you like, but you want to describe it to say that at x equal to 40, the revenue is maximized, or at x equal to 40, the revenue has a maximum, or the revenue has a maximum value, or at x equal to 40, revenue has a maximum value, or I'm repeating myself, or revenue is a maximum. Okay, so we say something like that. So at x equal to 40, the revenue has a relative maximum. Or you can say the revenue is maximized. All right. And now you want to describe the value of the R. And the maximum revenue is equal to what? The revenue is equal to the value tadi lah. The maximum revenue is $192,000. So here you are describing the critical point, and that critical point is the maximum. So you describe it in terms of what? In terms of a maximum value. So that's how you describe. Similar to what we were doing, actually. You are describing that point, and that point is the maximum point. Okay. Any question about that? Anything? So that is revenue. And then you look at example number 3. Okay, example number 3 is on the cost. So what we are given is the total cost. So you look at example 3, you are given the total cost, and you want to find how many units of output that minimize the average cost. So you don't want to find the minimum cost, you want to find the minimum average cost. So what you do from the cost function, you get the average cost. All right. So if you look at example number 3, that is how you do it. So you make use of the relationship. Average cost is equal to C over here, the quantity, and that will be equal to what? Will be equal to 1/4 x squared, that is the cost function, plus 4x plus 100, everything you divide by x. Okay, so what is it equal to? That will be equal to 1 over 4x plus 4 plus 100 over x. Now 100 over x is 100x to the power of -1. Okay, so here you have 100 over x, the last term, that is equal to 100 x to the power of -1. So that's how you got that term. All right, so that is the average cost. So now you have average cost, you differentiate. Okay, get the first derivative, and then get the second derivative, and then we conclude. Okay, all right. So we just go through the example. So you are given the average cost. You find the first derivative of the cost function. So nothing difficult here. So AC prime is equal to what? You take derivative of the first term, you got 1 over 4x, that will be 1 over 4. The second term is the constant, that will be constant. The third term, you got 100, okay, x to the power of -1. Okay, so you differentiate this term here. What do I get? I get negative, not negative, you keep positive first. You get -1, okay, multiplied by 100. And then x, you reduce by 1, that becomes what? -2. So make sure we do this before you just come up with the, you bring the x to the bottom. And that will be equal to 1 over 4 minus 100x over x squared. Or you can keep up the x to the power of -2. It's okay too. And then for critical point, all right, the AC prime is equal to 0. For critical point, AC prime equal to 0. What do I get? I get 1 over 4 minus 100 x squared equal to 0. So 100 x squared equal to 1 over 4. So x squared equal to 400. Okay, so x squared equal to 400. You take the square become the square root. So x is equal to the square root or 400 to the power of half. Okay, so or the square root, or you can write the square root of 400. Okay, you take the square root of 400, what do you get? We get what? We get 20. 20 and -20. All right, because the square root of 400 can be either positive or -20. So either you write macam ni or you write like that. Okay. So you have -20 and 20. So you conclude that this negative is not relevant. So that is excluded. Okay. Since x is less than 0. X less than 0 is not relevant. Okay. For application. But if you want to do the test, that's fine. You can do it. So now we only look at x equal to 20. Okay. So I want you to finish it up. Of course, everything is given there, but they skip a little bit. Okay. I want you to show every step. Okay. So what I would like you to do, you finish up the second derivative test. Okay, so you take AC double prime and compute the value, because the book didn't compute the value. All right, because they assume that it's already positive lah. Okay, but we should compute the value and then conclude. So you make the conclusion and describe. Okay, describe as per the first example that I was looking at. Okay, all right. Okay, now we look at profit. Oh, I don't think we can go to the next topic. Profit pun belum kabur lagi. Okay, any question? Anything? Okay, profit. We look at the profit in example number 5, example number 6. Okay, example number 6. Kita go to senang dulu. All right, the one that is easier is the competitive profit. Okay, so we go to example number 6, the competitive market profit. So I want you to read that question. Okay, the question that in the example, what is the revenue, what is the cost, and then what do you want to find? So read that question, please. Macam mana puasa? Okey puasa semua. Tarawih kena ada. In your kampung or in your place, do the mosque has to close at 10 o'clock or is it in certain state? Semua kan? I think semua pukul 10 kena tutup kan? Macam dekat Selangor, but they make 20 rakaat, but you still have to finish by 10. In Pahang, they finish by 10, but many mosques or surau they make only 8. So you have time, you don't have to rush. But some mosques they finish at 10, they do 20. So laju sikit. Okay, you got that example? So here you want to find how many units of the X to be sold to maximize profit. And what is the maximum profit? So that is the question. So in other words, you want to find what? You want to find the maximum point. And then you find the maximum value of the profit. So remember the profit is equal to revenue minus cost. So how do you get revenue? You are given the price. Okay, so you know revenue is equal to PX, and given the price is equal to 200, revenue is equal to 200X. So that is perfect competition. And then for the cost, okay, find cost. So what are we given? You are given the average cost. Okay, given average cost equal to what? Equal to 80 plus X. So you are given average cost. How do you find cost? Therefore, cost is equal to what? Cost is equal to average cost multiplied by the quantity, and that is equal to 80 plus X multiplied by X. So you got 80X plus X squared. Okay, so that is the cost, that's revenue. So our profit is equal to what? Is equal to 200X minus everything here. 80X plus X squared. Okay, and then of course you break out the bracket, you will get berapa tu? 120X minus X squared. So that is our profit function. It's a quadratic function. So just do the second derivative test. So what you do first is get the P prime. And what is P prime? P prime is 120 minus 2x. So you set P prime equal to 0 for critical point. Okay. Therefore, 120 minus 2x equal to 0. What is x? X is equal to 120 over 2. That is 60. So that is the quantity that give you the maximum profit, or that is the critical value of x. Okay, so if you want, you can call it x0. So that is the critical value of x. So of course you need to find p0. Okay, so you find p at x equal to 60. Oh, you got the critical point, or you can find p later, that's fine. Number 2, you take the second derivative, p double prime is equal to -2. All right, and that is a constant, so easy. So what you do now, at x equal to 60, you evaluate the p double prime, and it's a constant that is equal to -2, less than 0. So what? So profit is maximized at x equal to 60. So now you get the value of p at x equal to 60. All right. So at x equal to 60, if you already have got it there, then you just describe it. Okay. At x equal to 60, p is equal to whatever the value is. Okay. Do substitution by substitution. Now, if you do the substitution, what do I get? You will get the profit equal to berapa? Kita buat. Kita lagi. The revenue per unit is 200. That is the price. And then P double prime. Okay. So it doesn't find, okay, that question did not give you the maximum revenue. So can you determine the maximum revenue? So that's good, you know. They didn't finish up with the maximum revenue. So we need to find. So you substitute x equal to 60 into the revenue function. Okay, what do you get? Dalam buku ni dia tak buat. Okay, anybody? Cepat. You substitute into the profit function now. Tinggal substitute into the revenue. Profit function, this one. Senang aja nak cari ni. Okay, cepat. Anybody who get it, let me know. Tahu sini.
3,600.
Berapa?
3,600.
3,600. Everybody got it? So substitute now into the profit. Okay?
Yes.
So you got 3,600. So that is the maximum profit. So our conclusion would be to maximize profit. All right, to maximize profit, what do? We have to sell 60 units of the good. And what is the good? It doesn't matter. It didn't say what is it, just unit. 60 units of the good or of the product. And the maximum profit is equal to what? Equal to 64,000. No, $6,400. Betul ke tadi? 64,400. 3,600. I'm sorry. 3,600. Okay. So that's how you describe. All right. So you have to describe the point. All right. Of course, you already got the critical point, and that critical point is a maximum point. We know that, but you have to describe it from the perspective of the applied. application. So if it is profit, you just describe. If it is revenue, you describe that point. So in other words, what you are describing is you are describing what? We are describing the critical point in terms of the independent value, or no, the dependent variable and the dependent variable. Critical point, which can be a maximum, it can be a minimum. Okay, so you describe it as that. All right. Okay. Any question? Okay. Now we move on to example number 5. Example number 5, you have a monopoly market. Same thing. The only difference will be what? Will be the revenue function. So the revenue function will be the demand function. You multiply by the quantity, then we will get the revenue. So again here, you have to find the profit. So example 5, you know the profit is equal to revenue minus cost. So first one, you need to find the revenue, okay? And revenue is equal to PX. So what are we given? You are given the price equal to 168 minus 0.2x. Okay, so therefore revenue is equal to 168 minus 0.2x multiplied by x. So what you will get is a quadratic function. 168x minus 0.2x squared. So that is our profit. No, our revenue. Next, you have to find cost. And you are given what? You are given average cost. If you are given cost, then no problem. Okay, but you are given average cost. So cost is equal to the average cost multiplied by x. Okay, and that will be equal to, you are given the average cost 120 minus plus x multiplied by x. So what do we get? We get 120x plus x squared. So your profit, all right, will be equal to 168x minus 0.2x squared minus everything, okay, the cost 120x plus x squared. You break out the bracket, okay, then what do we get? You will get 48x minus 1.2, say 1.2 x squared. So here it become negative, okay? Here negative, negative. So 168 minus 20, you got 48, 0.2, negative 0.2 minus 1, so 1.2x squared. So that's what you get, okay? So now I want you to finish it up. Now everything is, of course, it's already being done in the book, okay? But the book skip a few steps because they just want to show the conclusion. What I want you to do, I want you to find everything, okay? Determine everything, show the value. You get the second derivative, evaluate, get the value, and then conclude. Okay, all right. And then you get the critical point, and then you find you apply the second derivative test, and then you describe, okay? Describe that critical point. All right? All right. So we are done. So that is 10.3. I give you already the questions on. Saya bagi ya tadi, question 10.3. Did I give you question 10.3? Yeah, application 10.3 belum bagi. So 10.3, I give you a few questions. Do number 10.3, do number 5, number 6. That is the revenue. 5 and 6 revenue. So you can do only one of them. All right, and then what trend maximize total revenue? So again, number 10 is revenue. So do 2 of them. Okay. And then the second part would be the cost. So you do 16, 17. That will be the average cost. And then the last part will be on the profit. So you can do, you know, number 26, 27. And then, okay. Okay, number 26, 27, 30, 36. And you can also try number 35. Okay. And then number 38. Okay, 38. That is the monopoly. And then, cukup lah tu, dah banyak dah. Okay, then you can try number 43. Lagi satu 43. Tu banyak tu. Tapi tak payah buat semua. Okay, buat macam revenue tu, you don't have to do all, you know, you do until you feel comfortable. So 10.3, I will just write down 5, 6, 10, 16, 17, 26, 27, 35, 36. 35, 36 ni can do only one of them. And then 38, 43. 38, 43 ni do both, okay? This one you have to do both, but others you may skip some of them. Okay. All right. So that will do it for the chapter 9 and 10. Okay, so 10.5, you don't have to do it because it's more of a rational function which we don't deal with. Okay, so for this chapter number 10, we do only 10.1 up to 10.3. So most important will be the second derivative test. So make sure we know that. And of course, you know, chapter number 9, you have the first derivative test. Okay. First derivative test is a good concept, you know, good understanding of the concept of maximum minimum. So once we understand the first derivative test, then to make sense of the second derivative test is more straightforward. Correct? Okay. So any question, anything? Okay. So I have a few more minutes. I have 10 more minutes. So we move on to the next topic. Aduh. Kita take a break 1 minute. 1 minute break. Bulan puasa ni kena take break 1 minute. Kuat juga bunyi benda tu. So get ready for the next topic. Next topic ni on partial derivative. Okay, partial derivative chapter berapa I think quadratic function tu, to find the roots. I think dia chapter 1 lah. I think it's in chapter number 1. Cari je lah. Okay, chapter number 1. Ada factoring. Dia chapter 0, ataupun chapter number 1, saya perlu ingat. Okay, so I think you can find. Adil kita ada. Dulu saya mampu. Apa cari sini ya. Alright, so the next topic will be partial derivative. Okay, now partial derivative is chapter number, I think it's chapter number 14. Okay, so here, all right, you have a situation where the function, okay, the function consists of two or more independent variables. All right, so next topic is on the partial derivative. Okay, so here you have a function, y, they have more than one independent variables. So you have x1, x2, x3, up to xn, where n, okay, is an integer. So you have, this is the general form, okay? That's the general form. For the, what do you call it? For function with two or more independent variables, then you have the function will be like this, all right? So to satisfy the condition, n must be bigger or equal to 2. So example, you have y equal to f of x1, x2, x3. So here you have 3 independent variables, all right? 3 independent variables, which are x1, x2, x3. Okay, and of course one dependent variable. The one that we already has considered or we already know is y equal to f of x1. All right, so if there are only one independent variable, we just write it y as a function of x. So this one we know. So here you have more than 2 independent variables. So to do the derivative, you do the partial derivative. So for us, okay, we only consider 2 independent variables, which is, if you go by the general form, will be x1 and x2. Okay, now since there are only 2 independent variables, normally you don't write x1 and x2. Of course, you can do it, right? But we use another notation. Z equal to function of x and y. So here, the y become the independent variable with x. The dependent variable will be z. So if you relate back to the general form, the x1 will be x, x2 will be y. Okay, the y now z, since there are only 3 variables. Okay, So normally, if you go to the chapter number 14, the notation will be z equal to a function of x and y. Okay, all right. So how does the graph look like? So if you look at this thing here, there are three variables. So the graph will be 3-dimensional. So you have the graph, it will be 3-dimensional graph. So you have a 3-dimensional graph, 3-dimension. Now 3-dimensional graph, 3-dimension. If you have y equal to function of x, this is 2-dimension. Okay, 2-dimension meaning you have y and x. Y the independent variable, x is the dependent. No, x is the independent variable, y is the dependent variable. Okay, but now you have 3-dimensional. You have two independent variables, x and y. That means you have a 3-dimensional graph. So how does the graph look like? So now, all right, now x and y will be the independent variables. Z is the dependent. So how does the Z come into the graph? If I start from here, okay, I start from here, the Z itu pergi mana? Macam mana nak draw Z? Kita boleh draw, okay, tak boleh draw. The Z will be what? Will come out from my screen here. Start dekat sini, okay, the Z will come out toward you. And then it also go down to the other side. Boleh imagine tak? Can you imagine that? Now everything is at 90 degrees. Okay, so here 90 degrees, this 90 degrees. So the Z axis that come out will also be 90 degrees up. So 90 degrees up and 90 degrees down. It's like what? It's like it's like a building. Okay, like a building that coming out from the earth. So that is the Z coming out. Okay, so if you imagine the line, all right, you imagine the line. This x and y x and y are the lines exist on earth, on the ground. The z will be what? The z will be the line coming up to the sky and going down through the earth. Okay, so you will get 3-dimensional object. So from there, what you get object. You don't get a line, you get object. Like what? Give me one example of a 3-dimensional object. Hello?
Cube.
Cube. Okay. Any object, cubic, sphere, or human. Okay. Anything on Earth, all right, is 3-dimension. So human, a house, everything, car. Okay, tree. All these are 3-dimensional objects. All right, and more formal, okay, more definite shape are the cuboid, okay, cuboid, and then sphere, cylinder, okay, things like that. So you got three. Now it's difficult to draw 3-dimensional object or 3-dimensional graph on a 2-dimensional space surface. So what we do is you look at the book in figure 14.1. Okay, 14.1, that's how you draw it. So you make the adjustment. Okay, you make the adjustment. We go back to what I have here. The x and y is on the ground. Okay, the z will come out to the sky and going down the earth. All right, so that is the third axis. So in order to show that z, what you do, you rotate the graph, then it will become like this. You have the x will going like that, going here, x, and then the y will go like this. So this is 90 degrees, okay, 90 degrees. And the z will come up like that. So X and Y to underground. Z is going up and underground. Okay. Now the one that we can see, okay, the one that we can see, imagine this is a wall, okay, imagine this is a wall. So the one that can see is the one that is positive in value, okay. So the positive X would be from, this is origin, this is the wall, okay. So the positive X is the one that come out. So here you got the positive value. The other side is the negative value. So negative value you denote by broken line. That is the other side. Okay. Now similarly for the Y that you can see, okay, would be what? Would be the positive. The one that you cannot see, I mean, beside the other side of the wall, that will be what? That will be negative. So we show it by the broken line. So this is negative. Negative Y. Similarly for Z, the one that go up to the sky, that's positive. The one that go down to the earth, inside the earth, you cannot see, that's negative. Okay, so that is our negative. So for more information, you look at figure 14.1. So that's a negative. So the first quadrant, okay, the first quadrant will be the positive X, positive Y, positive X. That is the one that we are looking at now, you know. And then the negative side, imagine that is something that you cannot see, it's blocked by the wall, okay. The wall meaning that going up. Dengan Y tu. So that's how you look at the graph. Okay, so I think I'm going to stop here. And then I will continue with the graph next class. Okay, all right, good. Okay, so I will see you again on Wednesday. So Wednesday, if you want to miss the class, please don't miss the class on Wednesday. Because Wednesday, I'm going to give you, you know, the rules, how to differentiate this kind of function. So it's very important. So if you want to miss, you know, you can miss a class. Actually, after this, you know, you shouldn't miss any classes. Everything will be more important. All right. Okay. I'll see you again. Any question? Any comment? Okay, good. So I'll see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Thank you, sir.
Thank you.
sir.
Okay, that will take longer, a little bit longer than normal.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you.